This one we just need to graph the data, so just plot those points. We have a point at $2.01. So just plot each of these points. So if you plot them, they all are in a straight line. You'll notice that these numbers are an arithmetic sequence. You're adding $2.01 each time. Determine if it's an arithmetic sequence. So arithmetic sequences are where we add the same number each time. You can check this with subtraction. Negative 15 minus a negative 9 gives us negative 6. Negative 21 minus a negative 15 is negative 6. And then negative 27 minus negative 21 is negative 6. So for number 2, is it an arithmetic sequence? We'd say yes. The reason is because our common difference is negative 6. Number 3, again, we can subtract to try to find that common difference. 1 minus a negative 3 gives us 4. 6 minus 1 gives us 5. So we already see that it's not an arithmetic sequence. It does not have a common difference. If we do 2.1 minus 3.6, we get negative 1.5. If we do 1.3 minus 2.1, we get negative 0.8. So we don't have the same difference, so it's not an arithmetic sequence. Arithmetic sequences are where we add the same number each time. Geometric are where we multiply by the same number each time. And then sometimes it doesn't fit either of those, in which case it'd be neither. Both is not a valid choice. There is no sequence that's both arithmetic and geometric. All right, so number 5, if we try to do addition, we quickly realize that it doesn't work. Negative 40 minus 20 is negative 60. 80 minus a negative 40 is 120. So not arithmetic. Now let's see if it's geometric. So let's write our ratios and see if they're the same. So if we do negative 40 divided by 20, we get negative 2. 80 divided by negative 40 is negative 2. And then negative 160 divided by 80 is negative 2. So we'd say it's geometric, and our common ratio is negative 2. All right, 6, if we do 8 minus 4, we get 4. 32 minus 8 is 24, so it's definitely not arithmetic. If we try ratios, we get 8 over 4, which is 2, but then 32 over 8 is 4, so it's not geometric either, so it's neither. And then for number 17, if we do negative 19 minus a negative 1, we get negative 18. Negative 37 minus a negative 19, we get negative 18. And negative 55 minus negative 37, we get negative 18. So each time we're getting a common difference of negative 18, so we'd say arithmetic D equals negative 18. To find the next 3 terms, we're going to keep this pattern going. We already know it's an arithmetic sequence. Negative 34 minus negative 38 is 4, so we're adding 4 each time. So next three terms, negative 26 plus 4 is negative 22. Negative 22 plus 4 is negative 18. And then negative 18 plus 4 is negative 14. Find the next term in the geometric sequence. So we already know we're multiplying. Do negative 20 divided by 5 to figure out what we're multiplying by. It's negative 4, and then multiply negative 320 times the negative 4, and we get positive 1280. And the next one asks for the next three terms in the geometric sequence. So keep the pattern going. Well, 1 divided by 5 is 1/5. So our common ratio is 1/5. Continue that pattern. 1/125, times 1/5 is 1/625. If we continue multiplying by 1/5, we get 1/3125, and then if we multiply that by 1/5, we get 1/15,625. So those are our next three terms of this geometric sequence. Here we want to write an equation for each of these, so we've got to figure out whether we're multiplying or adding, whether it's an arithmetic sequence or geometric. So for number 12, we're dividing by 6 each, or multiplying by 6, I should say, each time. Negative 144 divided by negative 24 is 6. So it's a geometric sequence. For geometric sequences, we use first term times the common ratio to the n minus 1 power. So first term, negative 4, common ratio 6, n minus 1 power. So that's our exponential equation that goes with that geometric sequence. And then for number 12, it's not multiplying, it's adding 20. So our common difference is 20. First term is negative 17. Now the equation for arithmetic sequences is a sub n equals a sub 1 plus n minus 1 times d, where d is the common difference. So our first term, negative 17. Next we'll distribute. Negative 17 times n is negative 17n. Negative 17 times negative 1 is positive 17. I'm sorry, a common difference is 20. What I was doing there. Let me fix that. 20 times n is 20n. 20 times negative 1 is negative 20. Now we'll combine those. Negative 17 minus 20 is negative 37. Here the first term, negative 7. Common ratio, what are we multiplying by each time? That's negative 3. Equation for the nth term, a sub n equals first term, negative 7 times the common ratio to the n minus 1 power. And then to find the 10th term, we're going to replace n with 10. So to find the 10th term, replace n with 10. 10 minus 1 is 9. And then we'll put the rest of this in our calculator. So our 10th term is 137,781. All right, here the first term is 810. They tell us the common ratio is negative 1/3. And then we're finding the 6th term in the sequence. So after we come up with the general equation, we'll replace n with 6. Six minus 1 gives us 5 for our exponent. And then we'll type all this into our calculator. So you should be getting either negative 3 1/3 or negative 3.3 repeating. Either one would be acceptable here. Here we want to find the 30th term in the sequence, so replace n with 30. Multiply before you subtract. So our 30th term in the sequence is 147. Arithmetic sequences are always represented by linear equations. If we graph them, they're lines. Geometric are always represented by exponential equations. Notice the variable in the exponent for geometric sequence equations. Here we want to fill in the missing terms, so we're going to continue this pattern. 1 minus a negative 8 gives us 9, so we're adding 9. 10 minus 1 gives us 9, so that is the pattern. We're adding 9 each time. 10 plus 9 gives us 19 for the missing term. And then on part B, 15 divided by negative 3 is negative 5. So we're multiplying by negative 5. 15 times negative 5 gives us negative 75. If you do negative 75 times negative 5, you get positive 375. So the pattern continues, multiplying by negative 5 each time. It's a geometric sequence.